In this video, we're going to focus on balancing redox reactions. So first, we're going to work on just simple reactions between metals and metal cations. Then we're going to work on balancing redox reactions under acidic conditions and in basic conditions. So let's begin. Now the first thing we're going to do is separate the reaction into two half reactions. So let's start with zinc. Zinc metal converts into the zinc 2 plus cation. Now, the first thing you want to do is you want to balance the atoms. So the zinc atoms are balanced. We have one zinc atom on the left side, one zinc ion on the right. Once all the atoms are balanced, the next thing you want to do is balance the charges. We have no charge on the left, but a +2 charge on the right side. So we got to add 2 electrons to balance it. You always want to add the electrons to the side with a higher charge. So this half reaction is balanced. By the way, this half reaction is known as oxidation. Whenever you have electrons on the right side, electrons are lost. Zinc gave away electrons, so it's oxidation. Now let's look at the other half reaction. We have Ag plus converting into Ag. So we have a +1 charge on the left, 0 on the right. So we need to add 1 electron to the left side to balance the charges. Now the next thing we need to do is make sure the number of electrons are equal. Anytime you have electrons on the left side, it's a reduction reaction. Now, before we can add these two, we need to make the number of electrons in both half reactions equal. So we're going to multiply the second equation by 2. And now we can add them. So we have, if we bring this down, we have zinc plus 2 Ag plus, because we got to multiply by 2. The 2 electrons will cancel. And on the right side, we have zinc 2 plus, and we're going to multiply that by 2, so 2 Ag. So now that reaction is balanced. Let's try another example for the sake of practice. So let's say we have magnesium 2 plus with Fe. Let's say it converts to, actually hold on. Fe 2 plus. Let's say it converts to Mg 2 plus and Fe. Now feel free to pause the video and try this example yourself and see if you can get the answer, and then unpause it when you're ready. So let's start with Mg. So the magnesium atoms are already balanced on both sides. So we have a charge of 0 on the left, a charge of 2 on the right, and so we need to add 2 electrons to the side with the higher charge. Now we have Fe 2 plus on that side and Fe on the right side. So the left side has a higher charge, so we're going to add 2 electrons to balance it. Now the electrons are already equal, so these will cancel and we can simply add them, which means that this is already balanced. Let's try another example. Al plus Cu 2 plus and Al 3 plus Cu. Now this reaction isn't balanced because the charges are different, even though the number of atoms are the same. So let's start with aluminum. We need to add 3 electrons to the right side to balance the charge for aluminum. So that's it for that half reaction. And this half reaction is known as oxidation. Now for the second one, we have copper 2 plus on the left and copper on the right side. The left side has a higher charge, so we need to add 2 electrons to it. And now, so the second half reaction, which is the redox reaction, or the reduction reaction, that half reaction is balanced. So now what we need to do is make sure the number of electrons are the same. So the least common multiple of 3 and 2 is 6. So we're going to multiply this equation by 2 and this equation by 3. And at that point, the number of electrons will equal. So we have 2Al, 2Al3 plus, and 6 electrons. And here we have 6 electrons, 3Cu2 plus, 3Cu. And now we're going to add the two equations. So as you can see, these cancel, and then we're left with 2Al plus 3Cu2 plus. And on the right side, we have 2Al3 plus 3Cu. And now it's balanced. Notice that the total charge on the left side is the same as the total charge on the right side. 2 times 3 is 6, 3 times 2 is 6. Both sides have a total charge of plus 6. So now we're going to focus on balancing redox reactions under acidic conditions. So let's say if you're given this reaction. How would you balance it? So under acidic conditions, you are allowed to add H plus or H2O to balance the reaction. Let's start with zinc. So we have zinc metal converted into zinc 2 plus. So we know we need to add 2 electrons to this half reaction to balance it. So that reaction is done. And now let's look at the next example, the second half reaction. We have bromate converted into bromide. Now we can't add electrons yet because we have to balance the number of atoms. We have 3 oxygen atoms on the left side. So what we need to do is add 3 water molecules. So the oxygen atoms are balanced. But notice that we have 6 hydrogen atoms on the right side. So we need to add 6 H plus ions on the left side. So now the atoms are balanced. Now we need to look at the charges. So if we calculate the total charge on the left side, it's 6 times 1, which is plus 6, and then we need to add this negative 1 on bromate. So 6 minus 1, that's a total charge of plus 5 on the left side. On the right side, we only have a charge of minus 1. So if you subtract the two numbers, if you take the larger number minus the smaller number, 5 minus negative 1 is equal to 6. So what this tells you is that you need to add 6 electrons to the side with the higher charge, which is the left side. And now that half reaction is balanced. However, the number of electrons are unequal, so we got to multiply this by 3. So we have 3 zinc atoms yield 3 Zn2 plus 6 electrons. So now we can add the two equations. So the electrons will cancel, and then everything on the left side of that line simply falls down to the left side. So we have 6H plus bromate plus 3Zn yields 3Zn2 plus Br minus plus 3H2O. And now that half reaction is balanced. Let's try another one under acidic conditions. Okay, feel free to pause the video and try this example. So let's begin. Let's start with aluminum. So all we need to do is add 3 electrons to balance the charge. And that's it for that half reaction. Next, let's look at hypochlorite. Now for this one, we have to balance the number of atoms before we can balance the charge. we have one oxygen atom on the left, so that means we got to add H2O to the right side. Now we have two hydrogens on the right side, so we got to add 2H plus on the left side. So now the number of atoms are balanced. Now we got to balance the electrons. The total charge on the left side is, let's see, we have 2 times 1, which is 2, plus this -1 charge. So we have a total charge of +1 on the left side. On the right side, we have a total charge of -1. So if we subtract the two numbers, starting with the large number, the largest minus the smallest, so 1 minus -1 gives us 2. What this means is we got to add 2 electrons to the left side, which is the side with the higher charge. Okay, so now these half reactions are balanced. So what we need to do next is to make sure the number of electrons are equal. As we said before, the least common multiple of 2 and 3 is 6. So we need to multiply this by 2 so we can get 6 electrons. And we need to multiply this equation by 3 so we can get 6 electrons. So let's rewrite what we have. So we have 2Al, and that yields 2Al3 plus with 6 electrons. Now on the bottom, we have 6 electrons plus 6 H plus ions. We have 2 hypochlorite ions. And we have 3 chloride ions. And 3 H2O molecules. So now we can add these two half reactions. So the number of electrons will cancel. So we get 2Al plus 6H plus and 2 hypochlorite ions. And that turns into 2Al3 plus 3 chloride ions and 3 H2O molecules. So now every atom is balanced. We have 2 aluminum atoms. Wait, hold on. This is supposed to be a 3. 3 ClO minus. So let's fix that. That's a 3. Okay, now everything is balanced. We have 3 chlorine atoms, 2 aluminum atoms on both sides, 6 hydrogen atoms, 3 oxygen atoms. And let's make sure the total charge adds up. So 6 times 1 is 6 plus -3. That's a total charge of +3 on the left side. On the right side, 2 times 3 is 6. And we have 3 times -1, which is -3. 6 plus -3 is 3. So the left side and the right side have the same total charge. Let's try one more example under acidic conditions, and then we'll try a few problems under basic conditions. Okay, so go ahead and try this example. So let's start with Fe. So the atoms are balanced, so we need to balance the number of electrons. So all we got to do is add 3 electrons to it. So now we can move on to the reduction part. So we have the same number of manganese atoms, but we have 4 oxygens on the left. So we need to add 4 H2O molecules on the right side. Now we have 8 hydrogen atoms on the right side, so we need 8 H plus ions on the left side. So next we got to balance the number of electrons. Here we have a total charge of 8 plus -1, which is +7. And here the total charge is +2. 7 minus 2 is 5, so we're going to add 5 electrons to the side with the higher charge. So now that half reaction is balanced. The least common multiple between 3 and 5 is 15. So we're going to multiply this equation by 5 and this by 3. So now we have 5Fe, 5Fe3 plus, and 15 electrons. And below that, we have 15 electrons, three permanganate ions, 24 H plus ions, 3 Mn2 plus ions, and 12 H2O molecules. So now we can add those values. So we have 5Fe plus 3 permanganate ions, 24 H plus ions, 5 Fe3 plus, 3 of those, and 12 H2O molecules. Okay, let's check to see if we balanced it correctly. We have 5 iron atoms, 24 hydrogen atoms, 12 times 2 is 24, 3 manganese atoms, and here we have 12 oxygens, and 3 times 4 is 12 oxygens. Now let's add the charge. So 5 times 3 is 15, 3 times 2 is 6, so we have a total charge of positive 21 on the right side. 3 times negative 1 is negative 3, and 24 times 1 plus 24, which is positive 21. So the charge is balanced as well. So that's how you can balance redox reactions under acidic conditions. Balance the atoms first by adding hydrogen or water, and then balance the charges by adding electrons, then add the two equations whenever the electrons are equal, and then you're done. So now let's try to balance these problems under basic conditions. So let's start with this example. Let's say if we have iron metal plus the hypochlorite ion, and let's say that turns into iron 2 hydroxide plus chloride. So let's start with Fe. So we have Fe turning into FeOH2. Now under basic conditions, we can add water and hydroxide. Like under acidic conditions, we could have added H plus and water. So what we need is, we got to add 2 hydroxide ions. So the atoms are balanced. The charge on the right is 0. The charge on the left is negative 2. So the right side has a higher charge. And these numbers differ by 2, so we're going to add 2 electrons to the right side. So now let's start with the other half reaction, hypochlorite converting into chloride. Now if we add hydroxide, we change the number of oxygens and hydrogens. So take a minute, think of how you would balance that second half reaction. Feel free to pause the video and try it yourself. Whenever you get to this point, it's easier if you add water to the side that has more oxygen atoms. So let's begin by adding 1 water molecule to the left side. Notice that we have 2 hydrogens on the left, 2 oxygens on the right. Whenever they're the same, that's good, we can balance it. So we're going to add 2 hydroxide ions on the right side. So the number of atoms are balanced. Now we got to balance the charges. We have a total charge of negative 1 on the left side, and here that's minus 1. That's 2 times negative 1, so negative 2. So we have a total charge of minus 3 on the right side. This is negative 1, this is negative 2. So negative 1 and negative 3, they differ by 2. So we got to add 2 electrons. Now which number is higher, negative 1 or negative 3? Negative 1 is higher on the number line, so we got to add it to the left side. If you have the electrons here on the right side, for the other one it has to be on the left. They both can't be on the same side. In one reaction, electrons are given away, and the other half reaction receives the electrons. Now fortunately the electrons are equal, so we don't have to multiply the half reactions by anything. So now we can add everything. So notice that the electrons cancel, but also the hydroxide ions cancel as well. We have 2 on the left, 2 on the right. So now we can add the half reactions. On the left side we have H2O plus the hypochlorite ion plus Fe. And that's going to convert into Cl minus and FeOH2. And that's it. And that half reaction is now balanced. So let's try another example. So let's say if we have iodide plus chlorate, and let's say that converts into the triiodide ion and chloride. So let's start with iodine. So we have I minus converting into I3 minus. So first let's balance the atoms. We have 3 iodine atoms on the right side. Let's put a 3 in front of on the left side. So the total charge on the left side is minus 3. On the right side, minus 1. And these numbers, they differ by 2. And negative 1 is larger than negative 3 on the number line, so we're going to add 2 electrons to the right side. So that half reaction is balanced. Now let's move on to the next one. So we have chlorate converted into chloride. So let's balance the number of oxygen atoms. So remember, we want to add water to the side that has more oxygen atoms. Because we have 3 oxygen atoms, we're going to begin by adding 3 water molecules. Notice that we have 6 hydrogen atoms and 6 oxygen atoms on the left side. So what that means is we need 6 hydroxide ions. So the atoms are balanced. The total charge on the left side is negative 1. On the right side we have negative 1 plus negative 6. So we have a total charge of negative 7. These numbers, they differ by 6. If we take the large number minus the small number, negative 1 minus negative 7 is the same as negative 1 plus 7, and you get positive 6. So negative 1 is larger than negative 7, so we're going to add 6 electrons to the left side, the side with the higher charge. So now, we need to multiply this equation by 3 so that the number of electrons are the same. So if we do that, we're going to have 9 iodide ions, 3 triiodide ions, and 6 electrons. So now let's add the 2 equations. Those will cancel. So we have 3 H2O plus 1 chlorate ion and 9 iodide ions. One chloride, three triiodide ions, and that is it. No wait, 6 hydroxide, almost forgot that one. Okay, so let's check our work. So the iodine atoms are equal, 9 on the left, 3 times 3 is 9. We have 1 chlorine atom on both sides. 3 times 2 is 6, 6 hydrogen atoms. We have 3 oxygen atoms there, another 3 here, so a total of 6. And let's add the charge. This is negative 1. Here we have 9 times negative 1. So negative 9 plus negative 1 is negative 10. Here's 3 times negative 1, so that's negative 3, plus this minus charge, plus negative 6. Negative 3 plus negative 6 plus negative 1 is negative 10. So the charges are balanced as well. Now, let's try another example. So let's say if we have sulfite plus this nickel hydroxide ion, and it converts to nickel and sulfate. Go ahead and balance the reaction under basic conditions. So let's start with sulfite. Sulfite converted into sulfate. So we need to add water to the side that has more oxygen atoms. So we're going to add an H2O molecule on the right side. Now the question is, how many H2O molecules should we have? Because we already have some oxygen atoms on the left side. So think about this. Feel free to pause the video and figure out how many oxygen atoms do we need on the other side. It turns out that we only need one water molecule. So notice that we have 5 oxygen atoms on the right side, 2 hydrogen atoms on the right, but we already have 3 oxygen atoms. 5 minus 3 is 2, and so we only need 2 hydroxide ions to balance it. Notice that if we add 2 hydroxide ions on the left side, we have 5 oxygen atoms on both sides and 2 hydrogen atoms. In the last example, the number of water molecules that we added was equal to whatever this number was. But in that case, it won't work in this example because we already have 3. So what you need to do, a quick method to find out how many water molecules you need to add to the right side, subtract these two numbers. 4 minus 3 is 1. So you need to add 1 H2O molecule. Then the number of hydroxide atoms you need is equal to the number of hydrogen atoms that you have on the right side. Since we have 2 hydrogen atoms, we need 2 hydroxide ions. And now it's balanced. The total charge on the left side is -4. This is -2, that's -2, so -4. On the right side, the total charge is -2, and they differ by 2. So the right side has a higher charge. -2 is higher than -4 on the number line, so we're going to add 2 electrons. So that half reaction is balanced. Now let's look at the other example. So clearly, we can see that we need 3 hydroxide ions on the right side. And the total charge on the right is -3. On the left, -1. So we need to add 2 electrons to the left side, since it has the higher charge. And -1 and -3 differ by 2. So the number of electrons are the same, which is good. So we can just add everything. Now notice that we have 3 hydroxide ions on the right side, 2 on the left. So if we subtract both sides by 2 hydroxides, this disappears and we have 1 left over here. So now let's add everything. On the left we have a sulfite ion plus the nickel hydroxide ion, and we have sulfate plus nickel plus water and plus a hydroxide ion. Okay, let's check our work. So we have 1 sulfur atom, 1 nickel atom on both sides. We have 3 oxygen atoms here and another 3, so 6. Here we have 4 oxygen atoms plus 1, that's 6. And we have 3 hydrogen atoms, 2 here plus 1, that's 3. The total charge on the left side, -1 plus -2 is -3. -2 plus -1 is -3. So everything is balanced. So let's try another example. So chromate plus magnesium converted into magnesium hydroxide and chromium hydroxide. So let's start with magnesium. So we can see that we need 2 hydroxide ions on the left. And the total charge on the left side is -2. It's 0 on the right side. So 0 is higher than -2. So we're going to add 2 electrons to the right side. So now let's balance chromate. So we have CrO4 2- and CrOH3. Now this one is going to be more complicated than usual. because we already have hydrogen present. So feel free to pause the video and try to balance it. This one is going to be harder than the other ones. So we already know that we should add water to the side that has more oxygen atoms. Generally speaking, that's if there's no hydrogen atoms present. But should we use that same technique in this case? What would you say? So initially, let's try this, trial and error. Let's say if we add water to the left side, that means we have 5 oxygen atoms and 2 hydrogen atoms. Now we want the number of oxygen and hydrogen atoms to be equal. The number of oxygen and hydrogen atoms on the right side are equal. And whenever you see that, that means this technique will work. You see how we have 4 oxygen atoms here? Let's add 4 water molecules. So on the left side we have 8 hydrogen atoms and 8 oxygen atoms, which is basically saying we have 8 hydroxide ions. And we have 3 hydroxide ions on the right side. 8 minus 3 is 5. So we need 5 hydroxide ions on the right side. And notice that it's balanced. We have 8 hydrogen atoms on both sides, 8 oxygen atoms on both sides. Well, fortunately that worked out pretty well. So now let's balance the charges. So we have -2 on the left side, -5 on the right side. So -2 is larger than -5, and if we subtract them, -2 minus -5 is +3. So we need to add 3 electrons to the left side. So we got to multiply this by 3 and this by 2. So we can get 6 electrons on both sides. So now we have 6 hydroxide ions plus 3 magnesium atoms and 3 MgOH2 and 6 electrons. So here we have 6 electrons, 8 water molecules, 2 chromate ions, and 2 chromium hydroxide formula units, and 10 hydroxide ions. So now we can add them. So these will cancel. Notice that these two are similar. So we're going to subtract both sides by 6 hydroxide ions. So that's going to cancel, and this is going to be reduced to 4. So it's going to be 3 Mg plus 8 H2O plus 2 chromate ions, 3 MgOH2, 2 CrOH3, and 4 hydroxide ions. So now it's balanced. But let's make sure. So we have 3 magnesium atoms on both sides, 16 H2O molecules on the left, 16 hydrogen atoms. Here we have 3 times 2, which is 6 hydrogens, 2 times 3, which is 6, that's 12, plus 4, so that's 16. We have 2 chromium atoms, 2 chromium atoms there. And now for the oxygens, we have 8 oxygens here, plus another 8, that's 16. 3 times 2 is 6, 2 times 3 is 6, that's 12, plus 4, 16. Everything is balanced. And then finally the charges. So 2 times 2 is -4, and 4 times -1, -4. So everything is balanced in this video. So that's the end of this lesson. And so now you know how to balance basic redox reactions under acidic conditions and under basic conditions, and you've seen